f of 1 plus I minus half times delta x, which is 1, times delta x, which is 1. So let's see how more exact it gets with 6 rectangles. I'm not going to write it in expanded form, but you can if you want. You can use this previous one, just change the 3 to 6, and change the 2's to 1's, right? What did you get, Andrea? 40.167. So, did the values get smaller or get bigger? It got smaller, right? So that technically means that what we are finding are over approximations, right? Overestimates. Okay, they're a little bit over, they're a lot less over than the right-handed one was, right? Okay. Or was the left-handed one over? I don't remember. No, the left-handed one was over in this case, right? The right-handed one was under. Pretty good? Right? So let's go ahead and compare our results. And when we do the trapezoidal sum, then we'll compare it with that one as well. So you're going to need your notes for the past 2 days so we can look at the numbers that you got for each case. And we can compare our answers. And I want you to go home and think about how we would do the trapezoidal one. See if you guys can figure it out. So the first one is the left-handed Riemann sums, which are the ones we did yesterday. Right? And they say with intervals of 2, which was when we had 3 rectangles, this was when we had 6, and this is when we had 12 rectangles. What did we get when we did the left Riemann sum with only 3 rectangles? For that problem, that last problem that we've been doing. 42.667, right? So let's write that down. And we didn't know if it was an over or an under unless we looked at the picture. So let's compare it to adding more rectangles. And my answer will get more exact. So then the second time we did it, we got 41.667. So now that I know my answer is getting more exact by adding more rectangles, I know that this is getting what? Smaller, so that means that they're over approximation. So now we can answer this question. Right? And what was the answer we got for the third case? 40.917. Was that still an over approximation? Yes. Okay. Then let's go back all the way to Monday for the right-handed one. What do we get for those? The first one was with 3, the second one was with 6, and the third one was with, not 13, 12. That one we got what? 34.667. Before I decide if it was over or under, let's add more rectangles. So the second time we did it, we got 37.667. So what happened to my approximation? It increased, right? So it's growing, so that means that my answers are under approximation. They're getting more exact as I add more rectangles, and they're growing. So the last one was what? $38.917, and that's still an under approximation. From the right, we seem to be approaching 40, and also from the left, as we add more what? Rectangles. Okay. And today, what did we get for the midpoint one? For this one, we only did 2 of them, the one with 3 rectangles and the one with 6. Because the answers are so close that we don't have to really do it with 12, we're already really close. What do we get for the first one? 40.667 and then 40.167. And both of those you can tell are what kind of approximations? Over, because as I added, my value got smaller. Up to now, which one do you think is the best approximation? Which one out of all of them? The midpoint with how many rectangles? Was 6. Do you think if we did the midpoint with 12, it would be even better? Yes. Okay, cool. So we still need to do the trapezoidal sums, and then we can compare those with what we have. So don't lose this paper, okay? Got it? So ultimately what you have to take home from today is the formula for the the midpoint Riemann sum, right? And the only thing that changed in the formula was that instead of adding 1 delta x, or instead of taking away 1 delta x, we're only taking away half a delta x. We good? Well, let's add that formula up here. Midpoint. So that will be the summation from I equals 1 to n f of a plus I minus half times delta x times delta x. Good? I'll try to come up with a foldable where we can label it Riemann sums and then have, the left, the midpoint, the right, and the trapezoidal. And you can write in all those formulas there so you can have them somewhere to study right before the AP test.
The last one,
Good? Right, so your assignment is again back from that same handout. Go back to it and do all the parts that ask you to do the midpoint Riemann sums, okay? And that's it for today. Sounds good? Yeah? You want more? No?
I am.
It's getting easier, isn't it?